Hello and welcome back. My name is Colton and you're here to learn programming with Go. And today we're going to be covering Boolean expressions and statements and how we can use them inside of if statements to customize the execution of our program. Currently, we've been writing programs that execute linearly. For example, we see that I have this variable called name and it's set equal to Colton, and then we print out saying my name is Colton, and that's going to execute 100% of the time each line no matter what. But what if we wanted to execute based off of the name value or maybe someone's age? We're going to need to use Boolean expressions and if statements to optionally run certain parts of our code. And so you may be wondering, why would I write a line of code that will never execute? I then implore you into this really weird abstraction when you think about how we as humans have near infinite choices to make, but we can't make all those choices at the exact same time or take all of the quote unquote execution paths at the same time. And while that sounds like an extreme abstraction, it really does relate to our programs in the sense that we want to account for certain decisions that a user can make and grant those choices to the user without giving every user the same copy-pasted journey, such as what this program is doing right here. It's always printing my name is Colton to the screen. Before we can review the if statement, we first must understand Boolean operators and how they can chain multiple Boolean expressions to create one final Boolean result. So the simplest Boolean expression that we can have is just assigning a Boolean called b, or whatever you want to name it, equal to the value or literal false. This can be false or true, but if we go ahead and run this, we'll see that false is printed to the screen. We can increase the complexity a little bit by using some comparison operators. So we can do 1 is equal to 10, which that's obviously a false statement because they are two completely different numbers. And so if we run this, we get false again, but let's go ahead and change this to 10 is equal to 10 to show that it actually will print true to the screen, which is exactly what we get here. But again, these are really simple statements. It's just a single Boolean operation going on and then getting stored into a variable. But what if we want to, up the complexity even more? Well, let's first go over the logical OR operator. Now, looking at the truth table of OR, it represents the different values that we can have for x, which would be our first argument, and y, which would be our second argument. Think of it as like a, like it says, like x plus y or x times y or however you want it to be. But for OR, it's kind of represented in the way of x plus something, but throw out the plus sign. It doesn't really mean much for what we're trying to do here. So if our first argument is 0 and our second argument is 0, or meaning that they are both false, then x or y or false or false will produce the false. Now, if x is false and y happens to be true, well then OR says, okay, then I'm going to evaluate the true. At least one of the arguments you gave me was true. And we can do the flip side. So if x is true and y is false, it will still produce true. And then if both of the arguments are true, then the statement will evaluate to true. So at the end of the day, at minimum, one argument in an OR chain must be true in order for the entire statement to evaluate to true. Let's go ahead and represent this in code. And my scenario here is going to be, I will go to get food or go get pickup somewhere on the basis that either 1, I have at least $10, or 2, I am not in my hometown. So let's write out these comments here just to make sure we have everything. So I have more, or at least $10, or I am not in my hometown. Now we're combining two different logical operators in this second statement. We're throwing in another logical operator here, which would be the negation one, but it's fairly easy to understand and we'll get there soon. So how we can first represent this is say I have current money, some current money variable, and we'll set it equal to 11 for now. And then we'll set a hometown. So we'll say, or current city, the current city that I may be in is San Francisco. We can represent this problem as a Boolean expression. So let's create another variable called go out to eat. And it's going to be equal to current money. And like we said up here, I have to have at least $10. So I will do greater than or equal to 10. And then this is an OR. So we use the double pipe symbol, or really it's just two single pipes. And so the other side of this is that I must not be in my hometown. So we'll say current city is not equal to West Lafayette, which is where Lafayette, where Purdue is located. Lastly, let's go ahead and print this out to the console. So we'll say go out to eat, question mark, a new line, and then we'll insert the Boolean the Boolean result here. So go out to eat. So let's go over this one last time. I have $11 and I happen to be in San Francisco. And so when this gets evaluated, it's going to insert 11 down here to current money. So 11 is greater than or equal to 10. So therefore we technically what is called short circuit here. And this entire expression will just evaluate to true. But let's go ahead and just continue. And the current city must not be West Lafayette. So San Francisco is not equal to West Lafayette. So this side of it is true. So at the end of the expression, when this gets printed out, I will be going out to eat. So we'll do a go run and we get true. So that's in the case that both statements happen to be true. Now let's make my current money equal to 9. Like I don't have a lot of money, but I'm not in my hometown. But according to the rules that we have created here, since I am not in my hometown, one of the expressions is still true. We will go ahead and get true printed to the console. So let's run this one more time and we get true. It looks like I actually didn't save from the last time, but anyway, it would have printed true. Okay, let's go through this again, going through the truth table here. Let's say I have $10, which meets the criteria here, but I am in West Lafayette. So one of these happens to be true. Let's run this again. I will be going to eat out. Now, one last one, the fourth option that we can have is I do not have enough money. So this is going to be false. And I happen to be in my hometown. So since both of the sides of this or are false, this will print out to being false. Go out to eat, it's false. Now let's go ahead and clean up this code a little bit more because I don't like how long this Boolean expression is down here. I like to kind of clean them up a little bit more. So let's go ahead and have another Boolean value called has enough money. And that's going to be equal to if current money is greater than or equal to 10. So it's just like what we had down here. And then we'll also say is in hometown, and that will be equal to if current city is equal to West Lafayette. Now you'll notice a bit of a discrepancy here because we're going to replace this expression with has enough money, and therefore we will replace this part of the logical or with is in hometown. But you can notice that this is not in the same vein as what the original rules were. This says if I have enough money or if I'm in hometown, but that's not right because I have to not be in my hometown. So therefore we can negate this statement by saying, okay, whatever this evaluates to, we will just flip the result. So we can just add an exclamation point before it. So now we can read this in a little bit more of a succinct way. This makes more sense because now we've placed names to the Boolean expressions that are being executed here. And so it's easy to read. It says, okay, if I have enough money or I'm not in my hometown, I will go out to eat. So let's just evaluate this again. So 9 is not enough money and I happen to be in West Lafayette. Let's execute this and we get that I will not be eating out for dinner or whatever meal it is. Okay, next up is the AND logical operator here. And this is, I would say, almost like the opposite of OR, whereas in both sides of the expression must evaluate to true in order for it to produce a true value. So if X is false and Y is false, then X and Y produces false. If X happens to be false and Y is true, we still get false because both of them were not true at the same time. Same goes for if X is true, Y is false. But if X is true and Y is true, then we get a true statement. Now let's go show this in code. Let's change up this scenario to I will own a dog if I have a house, so must have a house, and I must have a fence so that the dog can go run around and it doesn't have to, always be in my house. So let's go ahead and throw out all of these right here. And this is going to be a quick, straightforward one. So we'll have a variable called has house and we'll set it equal to the literal value of true. And then we'll say has fence and we'll set that equal to true. And then lastly, we will go ahead and have one final variable to evaluate the two things. And so we'll say can get dog and we'll say has house and has fence. So this is fairly straightforward here. I'll treat it just like kind of the Boolean tables that we were doing before. So can get a dog question mark. We'll save this. I have a house and I have a fence. So then therefore I can get a dog. Let's clear the terminal and now let's run this statement. So go run and it looks like I can get a dog because both were true. Now let's say I have a house, but I don't have a fence. So change the has fence to false. And then we go run this again and we say, no, I cannot get a dog. And then if I don't have a house and I don't have a fence, it also means that I cannot have a dog as the program prints out to me. So now that we understand the Boolean operators and some of the expressions that we can have, we can now move into what makes up an if statement. Now, Go's if statements are just like any other languages, except parentheses do not surround the conditions. And that's why I prefer to have the complex statements or the Boolean expressions wrapped into variables so that we can place meaningful names on them. And if statements have the following structure, and I'll go over the most simple one first. So we can say if, and then it happens to be some condition, so can get dog, and then we wrap it in braces. So this expression right here can be exactly what is wrapped in right here. So has house and has fence. We can use some or statement. It can be negated. It can be whatever you want, just as long as it evaluates to either true or false. And so this will be if I can get a dog, or it looks like if I'm eligible for a dog, then I'm going to go ahead and take this statement and we'll say I can get a dog, exclamation point. And we don't really need to print out the result of the Boolean expression because it's being used up here in the if statement here. So let's clean up the program just a little bit and have a more holistic view here. So has house is false, has fence is false, and so therefore I can't get a dog because neither of those are true when both of them have to be true in the first place. This line of code right here, 16, is not going to be executed. So let's go ahead and save. We'll clear and let's do go run, and we see that nothing got printed to the screen, which means that this statement got evaluated to false, and so we did not fall into this brace, and it skipped over this entire if statement. But since there's nothing after the if statement, no more lines of code were executed. Now we can have an if else statement, so all we have to do is say else at the end, and then we can go ahead and write in some custom code here. Now how this works is that if the above statement or the first condition of the if evaluates to false, then the next brace or the else brace clause will be executed. So I'll say I cannot get a dog, and we'll do frowny face. And so we save this, we do a go run, and it says I cannot get a dog. Now let's go ahead and show the other side of this truth table. So I have a house and I have a fence. We'll see that I can get a dog and that this will not be printed out anymore. So let's do another go run, and again it prints out I can get a dog because this expression evaluated to true. Now we can add some additional complexity here by having else if statements. So let's throw in another rule that I can get a cat if I have an apartment. So I will create a new variable called has apt, and I'll set that equal to true. And just for the brevity's sake of this example, we're going to say that I'm not in a house and I don't have a fence, but I have an apartment, and so that means that I can get a cat. So let's create another Boolean variable here, can get cat. Now this isn't necessary. This is kind of over engineering the solution by storing this expression in this variable, but it would be has apt equals true. Now this is redundant here because it's saying this true gets stored in right here. So it says if true is equal to true, and that's just redundant. So we can honestly just say this is equal to has apartment, but just for if you're new to programming, it might be easier for you to read and understand that as long as I have an apartment and it's true, that means I can get a cat. So let's add an else if statement to this. So we can say else if, and then put in can get cat, and then close the brace here. Now this is a little messy here, but how this reads is it will evaluate if I can get a dog. If I can't get a dog, then it will evaluate this expression. So inside of these braces, I will say I can get a cat, and this else statement still matters. It's still here. We can do something with it. And so we can change this to if the can get dog evaluated false and the I can't get a cat, then I can say I cannot get a dog or cat. So let's read through this. I don't have a house and I don't have a fence, but I do have an apartment. So when this linearly is executing and evaluating the statements, this will hit true. So we will fall into this and therefore skip the else statement afterwards. So let's confirm that this will say I can get a cat. So we run this and we get I can get a cat printed to the console. Now let's change has apartment to false. So at this point, it's basically saying, hey, I don't have a house and I don't have an apartment. I'm basically homeless and I cannot house a cat or dog at the moment. That means that I cannot get a cat or a dog, and that will get printed out to the screen. So let's run this, and I can't get a dog or a cat is printed to the screen. Now having this else statement at the end here is completely optional. It's just guaranteeing that some code will be executed if any of the above expressions were evaluated to false. So we can go ahead and just remove that, and then when we go to run this, nothing's going to get printed to the console because there was no code. Even after this brace, it doesn't have to be in an else statement. There was just no code to be run. Now we can also have multiple else if statements, but I encourage you to play around with these else statements and ifs and all that to get a feel of how you can customize the execution of your programs. So we covered quite a lot in this video. We covered Boolean operators, so the logical or, logical and the logical negation, and went over all the types of if statements that we can have. So the if else, and then the else, and then else ifs, and all that stuff to customize how we can execute our programs and maybe tailor them to be more specific to the user that is using the application. So you can now take this and you can run with it and have more fun programs. You can print, if numbers are even or false, and chain really complex statements. But be careful with if statements, because that causes your program to be indented more, and the further you go to indent your programs, the more mental tracking you have to do on all the previous conditions that have been met in order to get to that point in the program, and which we'll cover that in a future video at some point, to how we can architect our applications to be more readable for anybody to just sit and work on, and also make it easier for you to work on when you need to add more functionality. But anyway, I want to thank you for sticking around to the end of this video, and I'll see you in the next one.